Well, greetings everyone, and welcome to another Martinized Mentoring Moment with your host, Ron. Let's get a little contact information up on the screen. You can reach us at this number, or you can email us at helpforstem@mm.st. That's true, that's MM like the candy, M&Ms. Had a problem, changed cameras here. It came up the other day. This was quite interesting. Had to solve this camper here, shut up on electronic test. For what X are all of these true? Well, this had some interesting twist to it, and it's wanting you to recall one of the trigonometric identities, especially the power reduction trig identity. Let's see if we can switch screens right quick, and we'll go back over to that other one. Let's see, go back to screen share, go back over here. And there's a list of trigonometric identities on the Wikipedia page. So there's an excellent one here. There's a list of trigonometric identities on the Wikipedia page. In particular, this one is the most helpful when you kind of like pick through here trying to look for something to get rid of these cosine squareds. This one was the most useful right here. Cosine squared is all this stuff here. So we go back to our other camera and switch back to tutoring, and we'll get cracking here. So we move that 2 from underneath back out in front on this side, and now we have an exact drop-in replacement for that guy there and that camper right there. Now we got to watch that minus sign out there. So both of these are a drop-in replacement. So now we can rewrite this camper instead now as 2 minus, don't forget the bracket. Now we've got the 2 cosine x over 2. We'll come back to that one because we're going to write that one special. And on this side it becomes, the drop-in replacement becomes what? 1 plus cosine of 2 theta, or x in our case, because that was the original x, original variable. On this side, though, we sucked up the 2, but we left the minus sign outside. But we have to take care of this x over 2 and treat it as if it's a whole theta in itself. So this becomes, we do it careful here, 1, I gotta make sure we do it right here, 1 plus cosine, now remember 2 times whatever's in that box. So it's going to be 2 times 2, x over 2. I got to say it correctly. And those 2 will cancel, and this will leave us with 2 minus, don't forget the bracket, 1 plus cosine, I got to write correctly here, x is equal to, and make sure I don't mess it up, cosine of 2x again. Now this produces it quite fast. Now remember, we got a minus sign here, so that minus sign is going to get propagated across. So we get 2 minus 1 minus cosine of x equals 1 plus cosine of 2x. Notice what happens here. Nice simple algebra. 2 minus 1 becomes 1 minus cosine of x is equal to 1 plus cosine of 2x. And we take away the 1 from both sides, and we shift some stuff over, but we can also go this direction. We can go quickly. We can subtract 1 from both sides, move just to the other side, and this implies that 0 is equal to cosine of 2x plus cosine of x. Now that's a very special simplification. And we went from this up here to that there. This one will require us to recall a geometric interpretation, and there will be a second video for this one. Here's our polar axis. Here's our unit circle coming around. And if I do this correctly, we've got to find, now remember this is some, we had it over here, this is going to be some negative x plus, because remember cosine produces the output, from when we take the cosine of an angle, it produces the output of an x, plus x is going to give us 0. So somewhere over here is a second vector, over here is the first vector. This first vector, if we use theta instead of x, 2 theta in here, 2 and theta over here, and another one over here, 2 theta, the drop down vertical, this will be minus x, and the drop down vertical will be plus x. Okay, so we're going to illustrate that in another video, but this is the key to this solution. This gives you the first solution of this set. There's another solution when it comes back around. Now the question is, why would you ever have a problem like this? You have to think about clocks. This is like the minute hand, and this is like the second hand going around. And it's being driven. As this one's driven around, this one goes around faster. So you move the minute hand, and the second hand spins faster. But instead of 2, it'll be like 60x on a real clock. Okay, we're going to go to the second video. We'll switch screens here, and we'll come back to another video.